Howdy, everybody. Welcome to Technicals 101. Weird intro, I know, but let me explain. So, we've been dealing a lot with the event controllers and timer blocks and everything else that goes along with the AI in the last couple episodes. We've made turrets, we've made drones, but I do still get some comments asking how certain things work. I get DMs asking if I can troubleshoot, and trust me, I am more than willing to give as much help as I physically can. But I want to also give kind of a basic tutorial on how a lot of this stuff works. Now, I know a lot of the stuff on consoles is going to be a bit different, so I will try to go over that as well to the best of my knowledge and to what I can find either post editing or pre editing. But with that, let's start out with the basics, right? So before automatons, we had the programmable block and the timer block. Very simple. The programmable block, sadly, consoles can't do a whole lot with. Not a lot of the game changing stuff, I should say. So consoles have a thing where you're not allowed to have scripts that change the way the base code in the game works. You would be able to go in here. You can go to edit, browse scripts, and this is where all these scripts go that you subscribe to in the workshop. If you don't have any, that's fine. There's a little magnifying glass up here. We can go to browse and subscribe workshop items. Now consoles, yours is going to be through mod.io. There's still quite a bit in there. You just won't have as much stuff. So stuff like subgrid thruster manager, I don't think would be on there. I don't think Marmos would be on there either. Stuff that basically changes how blocks work or how different things interact, I don't think mod.io allows because it changes the base code of the game. I could be wrong on the specifics of that, but I know console has a lot less scripts because of coding issues that consoles have to abide by. But this is where you would go. Say you wanted to use Izzy's solar alignment. That's perfect. You would just go to that. You would subscribe to it. And then we would exit out. And it will be in here. You just click on that or select it and copy to editor. And then you will be able to configure it how you need to and do what you need to do in the script. You always hit check code just in case. Successful and okay. And then normally, if the author has done it correctly or properly, I should say, not correctly because you don't have to be correct. But if they've done it properly, then you'll see it actually just start running and try to do what it needs to do. I don't have any solar panels or oxygen farms, so it's not going to find any to move. But that's basically what a programmable block does. You can also use programmable blocks for all sorts of other stuff. If we go back to the scripts, you can see there's a height map visualization that I've used, fancy status displays, inventory managers, subgrid wheel controls, a whole lot of different stuff you can choose. And the most that you would have to do a lot of the time is, if we go back, change a couple things in here. So there's a couple settings you would have to go through or name certain blocks a certain way. You'll have to read the script that you got and see what you have to do. If you have an issue with that or aren't comfortable changing anything, or if you just have a question about the script you're looking at, send me a DM either through Discord. You can join our Discord in the link below. We will try to give you as much help as possible with this. any of this stuff we're going to be going over, just give us a shout. Next is the timer blocks. So timer blocks are kind of the one size fits all block. With timer blocks, we're able to set up different actions and put them on a delay. We are able to select a lot of different systems, whether it be rotors, searchlights, rotating lights, all of this stuff, and activate them all at the same time. Normally we would have a button do this, or an event controller, or something happens to where the timer block activates and does multiple actions at once. The only downside to a timer block is you can't put a delay on it. And we will get into how we normally get around that here in a little bit. So when we put stuff on a timer block, you'll have, let's say, the 2 searchlights. So we'll have searchlight 3, and you'll always get a list, not all of the options that a block has, but majority. We'll be able to target weapons, propulsion, but what we're going to do is just simply turn it on. And then same thing with the rotating light. Now, we're going to put this on a 2-second delay. And we're going to press start. Now, if we look up in the top right, it turned on, and we have our searchlight. Now, how we normally get around having the timer block not be able to have a delay on the individual actions, just on all of the actions alone, we simply just add another timer block. And then what we do is we come in here, we'll put it on a 2-second delay, set up actions, and we will just turn both of those lights off. And then we will go to our first timer block, and we will press start, because we want the 2-second delay from that one, and then it will turn them back on. And then all we have to do is go to our other timer block, set up actions, and add that second timer block, press start, and there we go. Now if we go back and we press start on this one again, it turned them on and turned them off. Now we can see by this indicator on the front which one is working. And if you listen, you'll hear that little beeping. I don't know why I just pretended to put my ear up to it. But the beeping is the countdown. So every one of those beeps is a second. So we set it to 2 seconds each. So it's just going to keep going back and forth until that actually just keeps going. And that's how timer blocks work. You can have different actions to stop those timer blocks with another timer block or with our next block. Or any block that can do an action can turn timer blocks on and off, or stop them or start them. They come in handy, and they can get very technical very fast. But on the basics, that's pretty much it. Now, our next one is the event controller. This is the most popular one right now, and this is the one that's been causing all the stir. Your drones are going to have the basic AI functions with the blocks that we'll go over later. But the event controller, the timer block, and the programmable block are pretty much what's running all of your drones that you see going on right now. With the event controller, if we go into it, think of it as a sentence or what's called a function. If you know anything about programming, functions are basically actions that the system will take based on certain parameters. So the event controller is just one big function. That's it. But the easiest way to think about these is to think of it in a sentence. So the way we do it is you have your event, your condition that it is looking for, and then the percentage, the threshold that it's looking for, and then the block that it's looking for that on. So what we are going to do is we are going to change cargo filled to block on off switched. Right? And then we are just going to look for rotating light past it. And we're going to add that. Pretty simple, right? You can see the big purple square in the back. So if our rotating light is switched on or off, we'll get rid of this. And we will select that light panel in there. So if the power is switched from the rotating light, we just want to toggle this block.
Fuel critical.
See it turned off. And it turned back on. Turned off. And turned back on. Very easy, right? Now, if I were to, say, go in here and go to stored power equal to or greater than, let's say, 80%. And we will look at all of our batteries and add blocks. And then we want to click this AND gate. So what the AND gate does is takes it from watching individual blocks, because without the AND gate, if one of these drains to 80%, it's going to do the action. If you choose the AND gate, it will wait until all of them are below 80% and then do our action. So if it is below 80%, we want to toggle off our light panel. And then we can just go to our light panel, make sure it's turned on, and we will be fine. Now, with the event controllers, this is how you will normally do miners, do guns, drones, that kind of stuff. All it is doing is looking for a certain thing to happen and then doing that action. So what we can do is we can go to all of our lights, put them in a group, and then what we can do is in the event controller, go to stored power equal to or greater than 80%. And we have all of our warfare batteries, or just batteries in general. Go to groups, the lights, and toggle on. Or, in retrospect, what we can do is go to our timer block and press start. Now we want to make sure that it is in the first slot. Okay? We want to press start. Now for the second slot, the slots on the event controller do matter. They're not going to both trigger at once. What it is the first slot is what is triggered when the condition is met. So when the batteries are above 80%, it will turn all of the lights on, or it will trigger that timer block. If the batteries go under 80% though, then it will trigger the second slot, which what we are going to do is press stop. Okay. Now we can go to slot number 2, and we can go to a timer block here, which will turn it on, or it will turn it off. So, the way we have this event controller set up right now, let's test our if sentence and see if it makes sense. That's the easiest way to get it, because normally if it makes sense when you're saying it out loud, it should work. So, if the stored power in our 4 batteries, and we have all 4 batteries because we have the AND gate, is equal to or greater than 80%, it will start the automation timer block and make sure that it's turned on. These don't have to be in a specific order, but we do want to make sure it gets turned on. Or if the stored power is less than 80%, because we have greater than selected, so if it's less than 80%, it's going to turn off that timer block and stop it, just in case. Make sense? I think so. So,
Fuel critical.
let me go ahead and turn off the reactor, and we'll slowly watch those batteries drain. Until then, these 2 will keep flashing on and off, and that will stay powered on. If those go out, we know we're down below 80%. Fair enough? I think so. Now, the next controllers we're going to be looking at are flight controllers, or task controllers. Those are going to be these. You have your AI flight, your AI recorder, and your AI basic task. So, we will start with the AI flight, because this is the easiest one. All you have to do is place it. More often than not, it's going to be set up in a pretty simple way, so there's not much to go over with this one. The only thing you have to look at is it is orient dependent. So the way it is facing determines everything about how your drone is going to work. So you can see it says front on this panel, and if we go to the side, it says right, because it's looking this way, so it's to the right. It has an L for the left, and if we look, it does have a rear panel. Now, the large grid blocks don't have anything on top, but the small grid ones do. So the front actually just has the F. You have a red circle with the L for the left. Rear panel just says rear panel. And then you have a green R for the right. And then you also have a rocket, I guess is what it would be. Or a missile. I don't know, however you want to look at it. The missile on the AI flight. There we go. Is pointing forward if I don't knock it over first. There we go. So it is actually pointing towards the front left corner. Something to keep in mind. If you go to put this on your ship and your drone start doing some weird directions, something like that, that's probably one of the things I would look at, is to make sure you put the blocks facing the right directions. Now, when it comes to the AI flight, we have AI behavior, collision avoidance, precision mode, your speed limit, altitude, pitch angles, aligning to planet gravity, and then that's pretty much it. What you would normally do is turn collision avoidance on or off, depending on what type of drone you're using. Precision mode on or off. Basically, precision mode just makes sure how close it wants to be to the waypoints that you set up with the next couple blocks we're going to be going over. So if you have precision mode on, it's going to be trying to get as precise as possible. but it also slows down the autopilot of the drone. So if you have a ship that is going for an intercept and you want to make sure your drone gets there as fast as possible, on one of the timer blocks that turn the AI on or that lets it take off, you can have that turn off precision mode and then put precision mode back on when it comes back to land. That way it slows down and does what it needs to do. Its speed limit is just the speed limit that it allows the full size grid to move. So your drone, your ship, whatever it happens to be, that's just the speed limit it allows it to move. And that is with precision mode off, by the way. So that is one thing to keep in mind. Precision mode, while it's on, slows down the grid, so this can be
Fuel
fully
critical.
up. Altitude, just the minimum altitude, basically. I mean, if your base is high off the ground like this one, you probably don't really have to worry about it too much. If you have a base that this ship needs to land underground, I would have something turn that off. Does it be acting very funny? Your pitch angles, basically, it's just the angle at which it allows the ship to pitch. So you have your pitch angles and your roll angles. That while the AI is flying the drone around, it's not going to let it go past 45 degrees left and right or back and forward. Normally, I set mine down to 30 just to be safe because I build my ships with less thrusters on the side and downward facing than I do forward and reverse and vertical. The reason I do that is because I'm the one flying them and I can control my ships. The AI, though, normally doesn't compensate for turning while or rolling while turning at the same time. It will correct it afterwards. It kind of does one step at a time. So I try to prevent any mishaps by putting it down to 30. But that's the AI flight. So it's what controls it. Next, we have the recorder. So this is the only other AI block that is dependent on which way it is facing. You can see it has the front, the right green circle, the left red circle, and the rear panel. The bottom one has the same thing, except instead of a spaceship, it has an arrow. So keep that in mind. It still faces forward, and it is the front left corner. So they both face the same direction. But what the AI recorder task block does is it actually records different waypoints. So this is what you would use to bring a drone in for landing, like we did in my patrolling drone video. Now, to actually get that to do it, there's two options. One, you can actually set it up to record, which it just starts recording a new path, but it does not. The one thing to keep in mind is it doesn't record curves. So say you're trying to make a circle around your base and you want to record that entire circle. You can press the record button and it will record that path, but it's not recording the path itself, it's recording points along that path. And it's going to draw a straight line to each of those points. So here's your record interval for when it takes a waypoint, and the minimum distance between waypoints needed for it to count as being recorded. So the easiest way to think of these two is if you go over 30 meters and it's been longer than 1.7 seconds, then it will make a waypoint.
Fuel critical.
Basic. I mean, that's about as basic as it gets. The other way to add waypoints to here is to have add waypoint on your hotbar while in your ship. That will add one waypoint every time you press it. You want to make sure you are not currently recording. And then what'll happen is when you want your drone to come in for landing, say you're just not comfortable landing, you can have just this and an AI flight block on your ship, record the waypoints for landing, do it the one time, and then after that, you have a self-parking ship, basically. That's the easiest way to put it. Next is the AI basic block. So this is similar to the recorder block, but the main difference is the basic task block doesn't generally have a distance requirement, or what's the best way to put it? You can't be, with the AI recorder, you have to be a certain distance from the first waypoint or the next waypoint for it to go to that waypoint. And I have not found the exact, but I think I was at about 3 or 4 kilometers and it wasn't wanting to do it. I can't remember the exact number, but it's a number that's not very large. Whereas the basic task block can send a ship to the moon or another planet. It goes off of general waypoints and will take the ship in that direction. So this is what we would normally use for like an autopilot system. Say you take off from your base, you go to the moon, you have the 2 separate waypoints, and it will take you to the moon's waypoint, do what you need to do up there, and then you trigger the second basic task block, because you can't have, if you have more than one waypoint for, let's say, the autopilot system, and we have it on one way, it will only go to the one waypoint. Here in the basic task block, we have our objective, our mode, and the waypoints that it would go to, and it gives you the list of all the GPS points you have. I have way too many. So, with the basic task block, this is more used towards going to farther distances or longer tasks, or like patrols or interceptions. Like if you were building a missile, this is the block you would want. So with the objectives, we have autopilot, follow the player. So if I follow that, I can hit follow me, and it will try to make the grid itself follow myself. And you can tell it how far away you want it to stay. And that's pretty much it. And it will constantly try to follow you. If we do follow home, this is where it takes a generalized GPS of where you're at. So this is normally for a beacon or GPS point that is on a rover, let's say. If you build a large rover, it's going to follow that rover. And normally you would try to choose the beacon of that rover. And then you can say set current position, which would be on that rover, the minimum range to keep, and the max range. So it can actually wander. Say you stop the rover because you're getting some ores or getting ice, or even just building a base. It can wander around while the base is not moving. If we choose autopilot, this is where we get our different modes. So we have patrol, circle, and one way. One way is obvious. I used it in my mining ore hauler drone, that it just goes to the one waypoint that you select for that. And then when it's done, it activates a second basic task block to go to the home base. And each one has their own waypoints. Patrol sets up multiple waypoints. Normally, you would have it in a circle. And then at each waypoint, we can choose, I believe, yeah. So if we choose patrol 1, if my stuff wants to work here, 1 through 6, it will go to each one of these waypoints, but it will stop at waypoint 6. And then it won't do anything. You would need to have to set up the action on waypoint 6, go back to your basic task block, and turn the AI behavior back on. That way, it starts back over. Because once it hits patrol point 6, it's going to turn the AI behavior of this block off. If we go to circle, however, it will keep going through these waypoints until otherwise told by either an event controller or a timer block, or it just falls out of the sky. Simple as that. That's all this block does, is just follow waypoints. Simple, right? I think so. But it also does not have an orientation, so you can set this anywhere and any way on your drone. Makes it even better. So, that is the basic flight blocks. Next, we have our combat controllers. These are what is actually going to control military drones, attack drones, and defensive drones when they go to either attack or flee. You can also put a fleeing response on like an ore hauler or cargo hauler to have it return to base or go into a certain point when it gets attacked or detects an enemy in the area. The first one we are going to look at is the defense block. Now, when it comes to combat controllers, one thing to keep in mind: the defensive combat block you can have it on at the same time as all of these other ones. Same thing with the offensive. The defensive one will normally just scan for enemies, like the assert spire there. If it got within 2.5 kilometers, I think it is, you can have it set up in action. That's where you can have it flee to a certain waypoint, trigger a certain beacon, toggle a certain timer block, whatever it may be. Whereas the offensive block does not have that option. It will just go and try to take out that assert spire. So, if we go into our defensive block here, we have a few different options on what kind of enemies and waypoints we want to do with this. So the first thing we have is, what kind of enemies do we want to defend against? Enemies, or just enemies and neutrals. This is basically telling the AI, I'm going to shoot at everything that isn't friendly. So I always just tend to keep it on enemies. Subsystems. Now, the enemy has to have this subsystem on it to be considered a threat. Now, we can make that weapons, which usually the obvious one. You want propulsion, which is any type of thrust. Power systems, like batteries, reactors. Communications, so any antennas, beacons. Or production, so any refineries, assemblers, O2H2 generators. That's basically what those are. So if we choose weapons, it's going to defend against only enemies that have weapons. So if one of those assert ships comes around that don't have any guns on it, it's not going to worry about it. It's not considered a threat at that point. Now our lock target, that just means what it says. Target locks to grid that meets the above conditions. Obvious, speaks for itself. Target characters. This is for more of like PvP, or there are some mods that spawn AI like robots or engineers. So those would be considered characters. You can have it target those. Or you can have it target wolves or the spiders if you play with those on. Those are considered characters. The flee trigger. So this is going to tell the ship when to actually flee. You can tell it to flee when it's only taking damage, when it's target locked, always or never. Now, when taking damage, if it was a neutral block or a neutral grid that had weapons and it was taking damage from that, it would set up the action or it would flee. The never just says, I'm never going to run. I'm just going to keep doing what I'm doing. And you don't get that action. Always means anytime it locks one of these targets, it's going to set up, or it's going to do the action. Or when target locked. Now, if you have anything except never selected, it's going to want you to choose a GPS point. This way, it sends the drone to that location, right? So we would choose drone home. Simple enough. Or what we tend to do with defense drones or combat drones, we will have it trigger as always, and our action would be to go to our AI offensive and turn the AI behavior on. When we turn on the AI behavior for the offensive block, it turns off automatically the defensive block's AI behavior. So it can take control and it will go take out the enemy. But that's pretty much it for AI defensives. What we normally use them for is for that action that we can set up. We don't get that option in the AI offensive block like I'll show you here in a minute. Oh god. Rotor in my way. So, with the AI offensive block, we have generally different options, and these are more of combat options. How you want the drone to act while in combat. This is why we use the defensive block to set the action to actually go to it. Because, yes, the AI offensive is going to be constantly looking for those enemies and constantly targeting them, but it overrides every other block anyway. So when it finds an enemy and takes it out, it will turn off its AI behavior. We want to keep doing that, so we turn on the AI defensive first. That way, when the AI offensive takes control, it goes to the enemy and then comes back, and the AI defensive stays true. So, our attack is going to be enemies or enemies and neutrals. Same thing as with the defensive block. I always just choose enemies because I don't normally shoot at neutrals anyway. Target priority. Just what it sounds. It's going to prioritize either the closest, the largest, or the smallest grids. That can be drones, that can be buildings, that can be bases. It can be large grid ships. So, whatever you want. Normally, I just do closest because I hate to say it, in a real world scenario, one closest to me is priority. Target search interval. So this is how often it will start a search and keep searching for enemies. You can have it search every 30 seconds, or you can have it search as little as, 5 seconds, or all the way up to a full minute. Normally, I'll turn this down maybe to 20, but not much more than that, because when it comes to drone combat, I want that drone to stay fixed on its target for as long as it needs to get it taken care of. If we have this down to every 10 seconds, it could be in the middle of a fight with another drone, see that there's another drone closer after it starts its target interval after that 10 seconds, and it will immediately try to go fight that other drone while the other one is still trying to destroy it. So it'll now be on a 1-on-2 fight, which brings our chances of success down significantly. So normally I'll keep that at like 20 seconds. Threatening subsystem again. Same options as the defense block. I normally just go with weapons. Attack pattern. Now, this is the movement of the drone while it's in combat. So, circle and orbit, just like it says, it'll try to circle or orbit the enemy at a customizable distance. The circle distance, you can have all the way up to 2,000 meters or down to as little as 100 meters. Normally with this, I keep it around 5 to 600 because a lot of small grid guns, especially like your Gatlings or your autocannons, are going to have a max distance of 800. So we want to be far enough away to where we can still land hits and for the enemy to have a greater chance of missing. So that's normally kind of the sweet spot, is between 5 and 600, I found. Stay at range. It, again, just what it sounds like. The grid will try to keep the enemy between a customizable min and max distance. So it's going to try to stay at least 200 meters from the enemy, but no more than, we'll say, 800. You can have this down to 0 or 2,000 for both of them. So you can stay within that. You can also trigger evasive maneuvers to where the grid will move randomly in this distance range that you set to try to avoid being shot. Hit and run. Hit and run is basically a strafing run. So it will charge at the enemy, it will fire when it gets within gun range, and it will keep firing. But when it gets to a certain distance from the enemy, what we have here is the break-off distance, it's going to stop firing and change directions. Normally with break-off distance, I stay about 150 meters to 200. Just to give the drone that time to veer off and avoid collision as much as possible, but also giving it the time to land the hits beforehand.
Fuel.
The retreat distance is how far away from the enemy am I going to go after I do the break-off distance. So this can be anywhere from 60 to 2,000. Normally with this, I go about 7 to 800. Like I said, the max gun range is 800 for the small grid guns, as like the autocannon and the Gatling gun. So I want to get just to that range, but I also don't want to go too far to where the enemy AI has time to turn around and start chasing, because if it doesn't hit that 800 meters, it will keep trying to get to that 800 meters. So we want to make sure it's a distance that's able to be reached, but not so long that the drone starts following it and it's still trying to hit that 800. Retreat timeout. Once it reaches that retreat distance, it will wait anywhere from 30 seconds to 1 second. And then it will start the process all over again. Now, the retreat angle. This is the angle from which the drone will go when it hits its break-off distance. At the break-off distance point, say we have this set to the 150. When it hits 150 away from the enemy, it's going to retreat at a specific angle that you set. You can leave it at 90, so when it hits the enemy, it goes to the side, and it will do more of an arc than it will a 90-degree turn. Or what I normally do is I bring that down to about 45, because then say we have this point here as the enemy AI, it will go to it and try to go this way. So that way the drone has to still turn to face us, but we're not still going straight and then have to turn around. We're not going 90 degrees and giving that drone a better chance of shooting at us quicker. We're just going to go 45 so we can still keep up that speed, get to where we need to go, and circle back around. The other thing to keep in mind is if you have the retreat angle at 0, it means the drone will keep going straight. After it hits that break-off distance, it will just avoid colliding with the enemy. It'll go around it, above it, below it, whatever it needs to do. 180 degrees means it will go to the break-off distance and completely turn around and come back towards it, or go back away from it the way it came. So that's another reason why I just do 45, just to get it a nice in the middle. But that's pretty much the AI offensive block. It's the one that actually does the combat, but it will also turn itself, the behavior off, and go back to the basic task or the recorder task. So this is why I separated them, because when it comes to flight controllers, these ones will continually operate or try to continually operate even in the background, whereas combat controllers will override the flight controls. So say we have a drone doing its patrol with the AI basic task block. It's at waypoint 3 with its patrol route. If it senses an enemy with the AI defensive block, it will, the way we had it set up was the action the defensive block takes will turn on the AI behavior for the offensive block, which then turns off the AI behavior for the defensive block. But that also allows the offensive to take flight control, go after the enemy, take it out, and then when it deems the enemy is no longer a threat, or there are no more threats in the area, it will then give control back to the basic task block and continue about its patrol. It sounds more complicated than it really is, but that's the easiest way to show it off or to explain it. The easiest way is to show it, and that's what I did with my patrol drone in the previous video. So hopefully this helps, and you can do quite a bit with a lot of these, as you've seen with our automatic miner, the patrol drones, the satellites and stuff like that. And you can do a lot with these blocks. The only other block that I have not touched on is the custom turret controller. The only reason I have not messed with that one in this video is because I want to give it its own video, because the turret controller can do a lot more than a lot of people think. because yes, you can set it to make solar tracking towers, so that way we don't need the programmable block anymore to make sun tracking towers. It can also become a literal controller for custom made turrets. It can become a controller for AI controlled turrets. And that, I think, deserves its own explanation and showing off. Plus, I have a couple ideas on some turrets I'd like to make with this. So, even though I've made a few already, there's a couple others I want to try out and see if they actually work. But I hope that has been a good explanation, or at least somewhat of a better explanation than what you've been given before. If not, let me know. Join our Discord, send me a DM, whatever you need to do. I will try to explain it a little better. And I hope you have a wonderful rest of your day. Good luck, and we will see you in the next video. Have a good night, everybody.